Okay, here's a continuation of 5.1, the identities that we need to learn. This time we're looking at cofunction identities and even and odd. We'll start with cofunction. Now, co in cofunction means complement. So the big idea here is that we're dealing with some complements of things. And I'm going to focus on this first piece right here. Now, these are written in radians. But if we think of them in terms of degrees and relate this back to your days in geometry, this says the cosine of 90 minus theta equals the sine of theta. Okay, so in words, what this is saying is the sine of an angle is the cosine of its complement. The sine of an angle is the cosine of its complement. Likewise, the second part right here, saying just the opposite. The cosine of an angle is the same as the sine of its complement. All right, so let's get an example here that you're a little more familiar with, and it has numbers in it. I'm going to get this to go down a little bit. And let me show you a triangle that you're pretty familiar with, something like this. That's your good old 30, 60, 90. Now, let's use what we had up here earlier. The cosine of 90 minus theta equals the sine of theta. So I'm going to switch the sides here. Let's say that the angle that we are looking at is 30. Okay. So let's say that our theta is 30, just for an example. Okay. So what that's saying is that the sine of 30 degrees is the same thing as the cosine of 90 minus 30. I'm replacing this theta here with the 30. Well, 90 minus 30 is 60, of course. So this is the cosine of 60 degrees. So what we have is the sine of 30 degrees is the cosine of 60 degrees. Well, let's look at that on our triangle here. If we're looking at the sine of 30, of course we're going opposite over hypotenuse. And you should know these from your unit circle anyhow, but the sine of 30 degrees is 1/2. Now if we're dealing with the cosine of 60 degrees, the 1/2 is now the adjacent side, and the hypotenuse is still 1. So again, you're dealing with the cosine of 60 degrees, and it is 1/2 as well. So the reason that the complements have their sines and cosines switched is because that their adjacents and their opposites are going to be the same. 60's adjacent is 30's opposite. And that happens for every single set of complementary angles. Okay, so those are the cofunction identities. The rest of them, work the same way, and they have the same pairs. Sine goes with cosine, tangent goes with cotangent, secant goes with cosecant, just like sine goes with cosine. Okay. Now let's look at the even and odd identities here. When we started looking at the graphs for sine and for cosine, we found out that the sine function was an odd function. That is, graphically it had a rotational symmetry. Cosine was an even. It reflected over the y-axis, so it was an even symmetry. And tangent was also having that rotational symmetry, so it's also odd. Well, that tells us a lot about our x's and y's and what's opposite and what is the same. And I'll show you the rest of these identities and why they're true here on our unit circle. So if we have the sine of theta, and Well, I want you to first of all notice that we have over here, we're looking at the opposite of theta in here, and these are all just plain old theta. Actually, I think I want to do that in a different color. I'm going to do that one in green. So here's theta. Now, on here, I'm just going to pick a particular angle, like 30 degrees, and that's fine. We're going to go and label this angle, this angle, this, of course. This is our theta that we're dealing with. Okay. This is theta. Now, if that is theta, then the opposite of theta is just going in a different direction. Okay, so there's our opposite of theta. So the right-hand side of your identities is dealing with the green, and the left-hand side is dealing with the yellow angle. They're just in opposite directions. So if we look at, say, the sine of pi over 6, we're dealing with 1/2. So the sine of pi over 6 is positive 1/2. Whereas if we look down for negative theta, the sine of negative pi over 6, well, it's the same value, but it's negative. We went down, so it's at negative 1/2. And that is why we have this identity that says that these two sine values are the same except for the two different angles, except for the fact that it's opposite. It just says that they're opposites of each other when you go in opposite directions. Okay, then we can do the same thing, same relative thing for the cosine, but things turn out a little bit differently. Now we're not talking about x and y values, or we're not talking about y values, we're talking about x values. So if I go up here at theta and I'm looking at the cosine of pi over 6, it's positive root 3 over 2. Now if I go down and go with the negative angle, the cosine of negative pi over 6, it's the same thing. I still went right. It's root 3 over 2. They are the same thing, and that's exactly what this says. The cosine of the negative angle is exactly the same thing as the cosine of the positive angle. They did not change. Notice that we had change going on with the odd function. With the even function, we did not see any difference. Now, tangent is going to behave a lot like sine, in that if we look back over here at our angles, with the green one, it has a tangent ratio or a slope for pi over 6. This is positive root 3 over 3. If we go down into the fourth quadrant with negative theta, it's the same steepness, but it's a negative slope, so its tangent value is negative root 3 over 3. So you see that the tangents are opposite of each other. Okay, so that does it for sine, cosine, and tangent. The same things will happen with their sisters, the reciprocals, with cosecant, secant, and the cotangent.